Okay, so today you're going to do 4.2, the natural exponential functions. The number e is defined as the value that 1 plus 1 over n to the n power approaches n becomes larger. So some key information with this is that the number e is used for the natural log. So understanding that e is classified as a number, so normally tend to round it off to about 2.72 often, but we can identify it on the calculator, and I will show you that a little later. The natural exponential function, so we talked about exponential functions earlier in 4.1. So the natural exponential function is the exponential function of f of x equals e to the x, meaning that e is classified as your base. So with graphs of natural exponential functions, the domain is always negative infinity to positive infinity, very similar to the last one. The range is where y has to be greater than our horizontal asymptote, or y has to be less than your horizontal asymptote. Remember, the horizontal asymptote is going to be y equals k, which is your vertical shift. So let's look at what the equation actually reads. It will look like this. Y equals e to the x minus h plus k. So understanding that your k value is your horizontal asymptote. Okay, so example 1 says graph the natural exponential function, state the domain, range, and horizontal asymptote. So we already know some key things that's already given. We know our domain is going to be negative infinity to positive infinity because that's always going to be the domain for our natural exponential. Then I have to look at what the range would possibly be. Well, we talked about our range earlier. Our range is our plus k value. Our plus k is 0. So the range is going to go from 0 to positive infinity with this. And the reason we know it's positive infinity is because there's no negative value in front of the e. So that means my horizontal asymptote is going to be y equals 0. So from here, I can go ahead and create a table. And I'm going to go and put this equation, putting the equation into my calculator. So the function says e to the x power. So what I'm going to do is I'll go to y equals, and I'll do e by doing second, the division sign, division. Notice how it gives me the e. The caret sign, which will be to the x power, and I'll graph it. Notice here, here's the graph. Also, if you want to see the table, so we'll do second graph to see our table. Notice that your table has positives and negatives, so I'm going to try to pick out anything that is maybe just right below right below 0 and just right above 0. So when I graph this, my table is going to read -1, 0, 1. And so what I'm going to do is go ahead and graph my horizontal asymptote, which is at 0. So this is the line that can cross over. And then I'm going to pick my points. So if I plug in -1 to this equation, you can put in your graph, go to clear or second quit. And I'll do second the division sign with the caret sign and put -1 in. And that'll give me 0.37. So about 0.4 is easier to graph. If I plug in 0, I get 1. If I plug in 1, I get about 2.7. So go ahead and plot these points on the graph. So at -1, I'm at about 0.4. At 0, I'm at 1. And at 1, I'm at about 2.7. So kind of mimicking the graph in your graphing calculator gives me the value. Let's look at example 2. So example 2 says graph the natural exponential function, state the domain, range, and horizontal asymptote. So remember, we know our domain. No matter what, our domain is all real numbers. So negative infinity to positive infinity. Our range, on the other hand, remember the range can be identified from our horizontal asymptote. So let's go ahead and list out our horizontal asymptote. Is going to be y equals our k value. In our case, our k value is 5. We'll look here at our equation. Notice that we have a negative in front of our actual well, our natural exponent, which tells me my range is going to go from negative infinity up to the value of 5 because of that negative in front. So let's look at how we begin to graph this. So in your calculator, you're going to clear, hit y equals, clear that as well, and we're going to plug in negative. Oops. So we'll plug in negative second division, e, that caret sign with the x plus 1. Make sure you scroll to the right a little bit so you can get below the exponential, plus 5, and we'll graph it. Notice how your graph is upside down. Good. So when I do this, I'm going to go ahead and graph what I do know, and that is the horizontal aspect. I know my horizontal aspect. To get as close to the horizontal aspect over it. So with this, I'm going to go ahead and form a table. So x and y. So the values that I'm going to choose for my table, let's put some negative values up into some positive. So I may choose -2, -1, and 0. The reason I'm choosing these values of -2, -1, and 0 is because if I kind of look at my graph here, I notice that everything below 5 is some of the points that I can pick a lot. The y values as well as what goes on with the x values. I have negative anything tells me that my x values are more so common over here for the negative, more so than they are the positive values visually on your graph calculator. So when plotting these points, I choose -2, I get about 4.6. I choose -1, it's about 4, and if I choose 0, I'm at about 20. So we're going to go ahead and graph these. So at -2, I'm up about 4.6, so close to about there. At -1, I'm at 4. At 0, I'm at 1, 2, 3. That tells me my graph does something like this, which mimics what I put in the graphing calculator. All right, let's switch gears into continuously compounded interest, which we talked about the last lesson, compounded interest. This is the formula for continuous compound interest you'll need to know, where A of t equals P e to the r times t. A of t is the amount per year, P is still your principal, r is your rate, and t is your number of years or your time. So example 3 says, a particular bacteria grows at a rate of 40% per hour, compounded continuously. If there are 5,000 bacteria present now, how many will there be after half a day? So when I'm looking at this, I want to go ahead and set up my formula, which says A equals P times e to the RT. So I also like to go ahead and list out what are the things that I know. So I know that my principal, or my starting amount, is going to be 5,000 bacteria. I also want to look at what happens with rate. About 40% per hour. So rate-wise, I'm at about 0.4. When I look at the time, look how it says how many will there be after half a day. Well, if some information here, you know that there's 24 hours in a day. Well, half of that would give you 12 hours. So our time is 12. And we don't know exactly what our A value is. So I have A equals 5,000 e to the 0.4 times 12. show you how you put this in the calculator, clear it. So you'll have in your calculator 5,000. You'll do second division to get the E. Put the caret sign. Go ahead and put your parentheses. Oops, sorry guys.